I'm recording this class so that I'll send the video of this video recording of this class, so that you can, if you want to revise this all, or if you have any doubt, you can go through this all and can ask me there in the next class. Fine?
Okay. Yes.
So last Wednesday, you were not present.
Yeah.
You joined little late.
Yeah, I wasn't sure about the timing.
Oh, fine. No issue. No issue. Actually, by that time when you joined, by that time I was not here. So that's why I was not able to take class. I left my place. So this is about metal. Should I go to the next one, beta?
Yes, teacher.
Now see. Next is non-metals. What next is? Non-metals. Non-metals are those elements which are having 5, 6, 7 electrons there in the valence shell. Non-metals are those elements which are having 5, 6, or 7 electrons there in the valence shell. So we'll be gaining, plus means gaining, will be gaining 3 electrons, 2 electrons, or 1 electron, to become 3 minus, 2 minus, 1 minus charged, and are electronegative elements. C, oxygen 8, nitrogen 7, fluorine 9, 2, 6. This is 2, 2, 5. This is 2, 7 configuration. So this will be gaining 2 electrons, so that in last shell 8 electrons will be there, and this will become O2 minus. This will gain 3 electrons to become N3 minus, and the configuration will be 2, 8. Stable. Here, this fluorine will be gaining 1 electron to become F minus, and configuration will be 2, 8. This will also become stable. So see here, oxygen is 2 minus, N is 3 minus, and F is 1 minus charge. 2 minus, 3 minus, and 1 minus charged. So to attain stability, to have 8 electrons there in the last shell, all these elements are gaining 3, 2, or 1 electrons. 3, 2, or 1 electrons.
Yes.
You are there in Singapore or UAE?
Singapore.
Singapore. So you are following that MOE syllabus?
Yes.
Okay, fine. So is this all over, beta?
Yes.
Should I go to the next screen?
Yes.
Now see. Metalloids or semi-metals. Metalloids or semi-metals means those elements which are having 4 electrons in the valence shell. 4 electrons in the valence shell. Having tendency of showing metallic as well as non-metallic properties. It will be behaving like as metal as well as non-metal. Fine. It's a matter of chance. If in front of them non-metals are there, then they will behave like as metal. And if in front of them, if metal is there, then their behavior will get changed and will behave like as a non-metal. So it's a matter of chance. Sometimes behaving like as metal, sometimes behaving like as non-metal.
Okay.
Fine, beta. So it is having the properties of both metal as well as non-metal, both. Carbon is having 4 electrons at its valence shell, but is not a metalloid. It's a non-metal. Carbon is a non-metal. If you know entire periodic table now, if you can draw entire periodic table, then I can explain you this very easily. If you do not know periodic table, then it will be little difficult for me to justify this all. Then if you'll be knowing periodic table, then just in minutes, just in seconds, we'll be distinguishing where metals are, where non-metals are, and where metalloids and where inert gases are there in the periodic table. So carbon is having 4 electrons, but is not a metalloid. It's a non-metal. So it is an exception. It is an exception.
Okay.
Inert, rare, or noble gases are also known as aerogens. Those elements which are having 8 electrons, valence electrons are 8. Those elements which are having 8 valence electrons are called inert gases, rare gases, or noble gases, or you can say aerogens. You know what is the meaning of aero? Aero means air, na? Atmosphere, na? All these elements, helium, neon, argon, krypton, xenon, radon, all these are there in atmosphere. All these are there in air. So are called aerogens. Since all these gases are there in air, na, in atmosphere, na, so are called aerogens. Is it done, beta?
Yes, teacher.
So these 4 types of elements can be there: metals, non-metals, metalloids, and inert gases. And every element, whether it's a metal, non-metal, metalloid, whatever it is, every element tends to attain this inert gas configuration, means having 8 electrons there in the valence shell. For this only entire chemistry is there. For this only chemical reactions are there. For this only chemical bonding is there. Just every element tends to have 8 electrons there in the last shell. That is the inert gas configuration. That is why entire chemistry is there. Fine?
Yes.
Should I go to the next screen?
Yes.
Now see, as you should know, sodium, potassium, lithium, hydrogen, these are 1 plus charged. These are 1 plus charged. Then
Yes.
calcium, magnesium, Fe, Cu, Ag, these are 2 plus charged. We should remember this all. Then aluminium, Fe. Here Cu also is 1 plus and Ag also is 1 plus charged. Al, Fe, Au, these are 3 plus charged. These are 3 plus charged.
Okay.
Now this is about plus. Now minus. F, Cl, Br, I, OH, NO3. These are 1 minus charged. These are 1 minus charged. Now SO4, CO3, SO3. These are 2 minus charged. Then PO4 is 3 minus charged. So at least this many ions you should know. This is the basic thing. What I'll do, I'll forward a ions notes paper so that you can go through that ions notes paper and can learn this all, and will be making your chemistry, your reactions very interesting, very easy. You need not to learn the reactions if you know all these ions.
Okay.
Have you done, beta?
Yes.
See what this is: sodium ion, what this is potassium ion, what this is lithium ion, what this is hydrogen ion, what this is copper 1 ion, what this is copper 1, or you can say cuprous ion. And here you have written copper 2 plus now. So this is copper 2 ion or cupric ion. What this is? Silver 1 ion. Silver 1 or argentus ion or argentus ion. What this is? Silver 2. 2 plus charge na? 2 plus charge na? So silver 2. Silver 2 or argentic ion. Silver 2 or argentic ion. Silver 2 or argentic ion. This is iron can also be 2 plus charge. Iron can also be 2 plus charge. So that is ferrous ion. Ferrous ion. And this Fe3 plus is ferric ion. Is ferric ion. This is auric ion. This is auric ion. So you should know all these names too, beta. Once metals are done, just let me know. So I'll explain this negative one. Once plus is over, then I'll explain this negative one.
Okay, done, teacher.
Done, beta? These are negatives. See, this is in plus na beta. In plus, suffix em will be used. Suffix em will be used. In plus na, suffix em will be used. Sodium, potassium, lithium, hydrogenium, cuprum, argentum, param, calcium. So in plus, it is em, and in negative, it is ide. Suffix ide will be used there in negative. See, fluoride, chloride, bromide, iodide, hydroxide, nitrate. What this NO3 minus is? Nitrate ion. What this OH minus is? Hydroxide ion. Hydroxide ion. What this SO4 2 minus is? Sulfate ion. You need to remember all these names. This is carbonate ion. This is carbonate ion. What about this one? Sulfite ion. What PO4 3 minus is? PO4 3 minus is phosphate ion. Phosphate ion. What PO4 3 minus is? Phosphate ion. So we need to remember all these names.
So what is a copper 2 called again?
Actually, see here, copper is showing 2 plus as well as copper is showing 1 plus.
Yeah.
So when it is 1 plus, then copper 1, and when it is 2 plus, then copper 2. Lower oxidation state, suffix us will be used. And for higher oxidation state, suffix ik will be used. So cuprous ion, cupric ion. Argentus ion, argentic ion. 1 and 2 you have specified because it is showing more than one oxidation state. So there you need to specify whether it is 1 plus or 2 plus, whether it is 2 plus or 3 plus, or 1 plus 3 plus, what it is. That you need to specify. That is why you are writing 1 or 2. That should be written in Roman numeral there inside the bracket. That should be written in Roman numeral inside the bracket. That should be written in Roman numeral inside the bracket.
Okay.
Done, beta?
Yes. Done.
Should I go to the next?
Yes.
See here very carefully. What you have written here, you have written this number in Roman numeral. What? Roman numeral. And it is there inside the bracket. Inside the bracket. So that is oxidation number. What it is? It is oxidation number. What it is? Oxidation number or charge. When oxidation number or charge is written in Roman numeral inside the bracket, that is called Stokes notation. Stokes notation or Stokes nomenclature. Stokes nomenclature. Fine, beta. Stokes is the name of scientist. Since that scientist gave the system now, so it is known as Stokes nomenclature or Stokes notation.
Okay.
Should I go to the next beta? This all is done.
Yes.
Now, should I go to the next screen, beta?
Yes.
Okay, fine. Now see, you have written FeCl2 or you have written FeCl3. What this is? This is iron 2 chloride. And what this is? This is iron 3 chloride. Or you can say ferric chloride. What it is? Ferric chloride. And what this one is? Ferrous chloride. That's the point. This is the utility of Stokes notation. This is the utility of Stokes notation. This is the utility of Stokes notation. Or Stokes nomenclature.
Okay.
C, Cu2SO4 and CuSO4. Cu2SO4 and CuSO4. See what charge SO4 is having. See here bit on the screen. SO4 is 2 minus now.
Yes.
So this Cu will be 2 plus.
2
Means
plus.
this is cupric sulfate. What this is? This is cupric sulfate or copper 2 sulfate.
Okay.
Now see, this SO4 as I told you is 2 minus now.
Yes.
So this, see here, this will be 2 plus. 2 Cu will be 2 plus. 2 Cu will be 2 plus. So 1 Cu will be 1 plus. So this will be copper 1 or cuprous sulfate. Is this okay, beta?
How come it changed to copper 1?
Copper 1, because see, 2 Cu will be having 2 plus, na?
Yes.
2 Cu. SO4 is 2 minus, na? So this will be 2 plus. What this is? This is 2 Cu. 2 Cu will be 2 plus, so 1 Cu will be 1 plus. 1 Cu is 1 plus, so that is called copper 1 or cuprous sulfate. See here, it is written that copper is 1 plus charged.
Yeah.
Cuprous sulfate or copper 1 sulfate.
Yes. Okay.
Now, should I go to the next screen, beta?
Yes.
Now, this will be for you. Let's see whether you will be doing it or not. PO4 3 minus, combine this with sodium, combine this with Mg, and combine this with Al3 plus to get sodium phosphate, magnesium phosphate, or aluminium phosphate. Sodium phosphate, magnesium phosphate, and aluminium phosphate. Just write the formula of all these three. Sodium is 1 plus, magnesium is 2 plus, aluminium is 3 plus, and phosphate is 3 minus. So how you will get it? After 10 minutes around, beta, this class will be stopped. So rejoin, please. Huh?
Okay.
Rejoin through the same link.
Okay. For sodium phosphate, it's Na3PO4.
Very good, beta. Very good. Very good.
Then
What
for
about sodium, magnesium phosphate?
Mg3 and then bracket PO4 2.
Whole twice. Mg3
Yes.
PO4 whole twice. Very good. Very good. This will help us a lot there in chemical reactions.
And then for aluminum phosphate, it's just AlPO4.
Yeah, that's all. Very good. Very good. That's all. So easy it is. So easy. Why I told you to do this? Just see NaCl plus H3PO4. MgSO4 plus HCl. AlCl3 plus H3PO4. Now see, this is plus, this is plus. This is minus. This is 3 plus. 1H will be 1 plus 3H will be 3 plus now.
Yes.
And PO4 will be 3 minus.
Yes.
Now see here, this plus will combine with this minus. This plus combines with this minus. So what you will get?
Okay.
You will get Na3PO4.
Yeah.
You will get Na3PO4.
Okay.
Just to see on the screen, beta.
Yeah.
See here, this is 1 plus now.
Yes.
This plus can't combine with this plus now. Plus will always combine with minus.
Yes.
Interchange na. So this is 1 plus, this is 3 minus. So what will get? Na3PO4. This is what you have written there in the previous screen na, Na3PO4.
Yes.
Now see, Na3PO4. How many Na you have written there? How many Na are here?
3.
And here it is
1.
1. So write 3 Na. Is this okay, beta?
Yes.
Now 3Cl and 3H. 3H and 3Cl will combine together to form thrice HCl. This is sodium phosphate. See, so difficult reactions you can write so easily without even learning. Forget about learning. Even you need not to read these reactions. And here you have not only written products by yourself, but you have balanced it too. This balancing is one of the difficult most topic, but that too you can handle. That too you can handle. Is this clear, beta? First reaction is clear?
Yes.
If any doubt is there, just please ask me. If any
Okay.
doubt is there, just please ask me. Then accordingly, second and third, you will be doing. If you have any
Alright.
doubt, ask me, please.
Okay. Which I'm done.
Done. Second is done, beta?
Yeah, everything I've finished.
Okay, fine. Tell me what the answer is. Your device is a touch screen.
Yeah, I write on my laptop.
So can you write it here on this screen?
Oh yeah, can.
You can write it. I have enabled you. You can write it.
Okay.
Yes, very good. Very good. Very good, beta. Very good. Fine. Very nice. Next one, last one. Very good. Very good, beta. Very good. So nice of you. See, Ashita, here I didn't give you products. You yourself only predicted about the products. Not only
Yeah.
you wrote products, but you wrote balancing also. That is one of the difficult most topics there in the chemistry, beta. So easy chemistry is.
Yes.
So easy chemistry is. Very nice, beta. Very nice. Now I'll give you some more reactions so that I'll get an idea whether your concept is clear or not yet. What this is lead 4 or plumbic chloride. Lead 4 or